good afternoon and welcome to this roundtable. So many of you have heard about digital twins, and now imagine digital twins under steroids, meaning hyper-boosted. That's because we're bringing AI into the equation. So with me today is a group of athletic scientists. So please, could you introduce yourself in less than a minute? Brigitte?
Thank you. So I am Brigitte André-Novel. I am a professor at École des Mines de Paris on control systems theory, robotics, autonomous vehicle, and recently I am responsible of a new institute, which is called Institut de Transformation Numérique, Institute of Digital Transformation, which is dedicated to digital transformation at the benefit of society. And we have to handle multidisciplinary projects and drawing on the pools of researchers at Mines Paris, about 200. We have to develop three key strategic areas. The first one is about digital engineering. The second one is digital health. And the third one is about cultural and creative industries.
Okay, good afternoon. My name is Guy-Alexandre Grandin. I'm deputy head of R&D lab at ENGIE Lab Crigen. It's a corporate R&D center of ENGIE. I'm dedicated to explore what could be the new energy use within an industrial context. And I have also a second hat. I'm expert or technical referees as a digital solution applied to industrial processes. That's why I've been involved in many different projects regarding Industry 4.0, like remote assistance, mixed reality, immersive collaboration, and also digital twin. That's why I'm here. I'm trying to share some new perspective.
Hello. Yeah, I'm Kunal. I'm Kunal Suri. I work for the French Commission of Atomic Energy in Paris. And I'm a computer scientist, and I'm also European project manager. So I manage European projects with the European Commission. And I work on digital twins. I work on generative AI. And the application of generative AI and digital twins to Industry 4.0, Industry 5.0, to healthcare and to energy. I write proposals for getting new funding for new research. And yeah, that's it. And today I think I'm very happy to be here with the ENGIE booth and with all the esteemed speakers. So I think you will have a good time. Thank you.
Mihir?
Mihir Sarkar. I'm head of AI at ENGIE Research and Innovation. So our goal is to apply artificial intelligence to the energy transition. I'm also a professor at Sciences Po Paris in AI and deep tech. And I'm also on the board of the MIT Club de France, who's co-sponsoring this talk, which is part of the Powered by AI series. It's a talk series that brings together researchers, startups, and industries on topics at the intersection of AI and the energy transition. And we've been having this regular talks for a while now. And I'm really excited that we're organizing this today about digital twins in collaboration with the Emerging Sustainable Technologies report that Elodie has been leading.
Thank you, Mihir. So I'm Elodie Dufournel, lead scientific advisor at ENGIE R&I, and I'm in charge of Prospective Watch and strategic research partnerships. So today, we are here to talk about digital twins coupled with AI. And this is actually a chapter of this year's edition of the Emerging Sustainable Technologies report, which is dedicated to the defossilization of the industry. So, as you know, this report focuses on technology that have the potential to accelerate the energy transition. So first of all, we need to make sure that we are all on the same page. So let's define some keywords, Mihir.
All right, so we're going to talk about digital twins. But I think through my experience, at least talking to different people who address their systems and the kind of work they're doing with digital twins, they have different meanings. So I'd like to maybe start with you, Guy-Alexandre. what you put behind the definition of digital twin.
Okay, there is not only, as you said, there is not only one definition for a digital twin, so I'm not going to be the guide or to say that that is the right answer, but let's say that for us at ENGIE, we consider the digital twin as, let's say, you have to consider a twin, a connection between a physical asset and a virtual asset, and this connection has to be in real time, all fully connected. That means that I can communicate between them, and it could be, this asset could be a process, an engine, a machine, could be a human as well. I mean, it depends on what you like. But the main point of being a digital twin is to be connected. Because if you compare with a brother and sister, you can have a brother on another brother, but it's totally different with the twins. The twins, you have a deep connection between the both. So this is more or less the same thing for a digital twin based on virtual assets.
Kunal, do you have a different definition or an additional definition?
I think what he said makes total sense. But we can think about digital twin also as replicas sometimes, which could help us to make decisions. The main aim of a digital twin is to have a decision. This means you want to take option 1, 2, or 3, or you want to understand if your system is working properly or not. So I think the decision-making support is very important in digital twins.
Does it make a difference if we talk about equations or if we talk about a visual representation? Do you have an opinion on that?
Yes, perhaps I can give an example in the context, for example, of controlling industrial plants. We want to mix a digital framework and AI techniques to control those systems. An example is, the case of an industrial chair, which is called twin heat, and the context is a glass industry, and we want to decarbonize this industry. And the idea is to define, for example, a model which is obtained from very time-demanding computational fluid dynamics, and then training the system on this kind of numerical system, and then produce a digital twin which is physically informed, but which can decide much faster, which can predict much faster. And in the second step, we can also think about using reinforcement learning to obtain a system, another digital twin, which can now decide and which can react on modification of the environment. So in fact, you have different digital twins which can be used to perform, to optimize glass furnaces, and the final objective, for example, is to obtain the neutrality carbon by 2050.
Thank
So
you,
if we go
Brigitte,
to the next keyword that we want to define, so AI, digital twins coupled with AI, how would you define AI versus generative AI, which are two big domains that can be applied to the industrial sector?
AI versus generative AI definition.
Yes, perhaps I think generative AI is how we can generate new objects from physics or from digital twins, in fact. I just would like to, once more, to take an example. At Mines Paris, we are member founding of Paris University, Paris Sciences et Lettres, which includes scientific but also artistic schools located in Paris. And the fact that we try now to use generative AI tools is very important in the context of cultural and artistic teams. I want to mention an example that we have used diffusion models to illustrate classical music, and we obtained 3D images, or 2D and 3D images, and 3D elements can now be generated using NLP, natural language. And just an example, yesterday I was at Station F and I met a new company which is called Fatter AI. And using the natural language, they can produce very fast 3D environment which can be used, for example, in our architecture or in construction industry.
So it's interesting, we can merge both AI on quantitative data with generative AI with more unstructured data in the context of industry. So final question in terms of defining the context in which we're operating. You work a lot with industry, and you talked about Industry 4.0, Industry 5.0. Could you explain a little bit what you mean by those terms?
So the Industry 4.0, 5.0 has been existed for like 5-6 years now, and it was firstly a German initiation for German industries in 4.0. And the 4.0 was mostly about automation, but the 5.0 is more towards automation with human in the loop, which is more about human-centric automation. We should not forget humans. It's an important part of the work. So I think that's the basic things, and also about sustainability, also about resilience, because now we are seeing in Europe what's happening, that we have problems with some things coming from China or something from US, some tariff plans, and we will need to have resilience in the supply chains, in the value chain systems. So these things have been started to tackle in the Industry 5.0 perspective.
Okay, thanks.
Okay, so now we have the definition. This roundtable is organized in 3 phases. First, we'll discuss the uses of digital twins, then what AI and Gen AI can bring to them, and we'll finish with a return on experience, so what works and what does not. So let's start with the question. So we already had some use case, so let's go beyond the buzz. When we talk about a digital twin, what are we really building and why? So maybe Guy Alexandre?
Yes. So yes, at ENGIE we have built a digital twin of industrial furnace operating with a blend of hydrogen and natural gas. It was a full value chain of the digital twin. It was based on first an IoT platform, secondly a capacity to perform 3D simulation in real time on demand. So it was based on reduced order modeling. It's a little bit difficult. It's a little bit different than AI because it's not the same approach in terms of reducing the complexity of the system. And then when, due to the fact that we are talking about digital twin, AI, etc., with the base of everything is the data, and it is the volume of the data, because we are producing a lot of data and in different ways. So we need at the end, like a third block, a way to understand this data and to make it, understandable for people working with the digital twin. So we have developed a mixed reality application to watch in real time what is going on. It's inside the furnace. I mean the flame, the turbulence, etc., to make it accessible to all the operator on site. So that's more or less an example that we made. That we learn a lot of things about all the difficulty to put everything all together, because we learned by doing. It took 3 years almost to do everything. I mean, it works. First thing, it works. It works well. It's wonderful. But the point is, it's like a millefeuille of something, because the first thing to keep in mind is you have a lot of different interfaces, a lot of different software, a lot of different versioning of software, a lot of different of people with specific skills. So it's like you're managing a big teams, a team of people, a team of tools, and a team of purpose as well. So it's a huge thing, but it works.
Okay, maybe Kunal, you have some other examples?
So in digital twins, normally we talk for different maturity levels. So you have a digital mirror. So when I say mirror, means you can take a photograph of something, and it's a digital twin. Or you can have a digital twin which is more like a shadow, in which you can transfer the data between the twins and to see and to analyze. For example, if you have a robot, and you have to see if the robot moves properly. You can make the robot in a simulation. You can make it move, and those data can be moved to real robot in the real time. So they have different maturity models of digital twins which could be used, and actually it's a very abstract word. So everybody's coming up with their own ideas. For example, Dassault System, they use the word virtual twins. So it's good to know that the number of words are bigger, and the idea is to give a good definition, a good decision for some good work.
Thank you, Kunal. And
As perhaps
Brigitte?
a sector which is very touchy is digital health. If we build some patient digital twin, in fact, the problem with is that are we able to interpret the results, and it is very important for medicine because it touches to the human being. So I think we are not able to be sure on the interpretability of the results, and perhaps what we could do is in the final validation stage, that is when we have to fine-tune, for example, digital twins, it should be done by the very experts, by the people who know best the ground truth.
Just if I can add something, just because about the lesson learned about doing a digital twin is instead of it's not very interesting to do it just by the sake of it. It's more interesting to see it like a machine to generate a lot of data and a lot of data of quality with high value. Because if you consider that you have the ability to produce a lot of value, a lot of data, you can use this very high value data to train AI, because the way to reduce the complexity, to make simulation faster within a digital twin using ROM, reduced order modeling, could be is a good way to limit the accuracy. I mean, to be sure about the value, and give correct and relevant information to data set to train AI afterwards. So it's a wonderful machine to produce high value data.
Okay, thank you. So you anticipate my next question, which was what are the capabilities that set digital twins apart? So maybe the next one would be, are there any areas where digital twins have not lived up to the hype? What are the limits and the weaknesses of the digital twins?
What are the limits of the digital twin?
Limits and weaknesses. Yeah, maybe in terms of precision, cost, I don't know.
I mean, so far the limit is just it's a question about of doing, let's say, it's a question of price first, the limit, because it costs a lot, and you have to if you want to implement a digital twin, whatever will be the level of simulation you want to keep, but it's a question of to implement properly for within the process. I mean, for getting the physical replica you want to replicate, if you want to mimic. Could be human, it could be human, it could be a machine, it could be a process. So the level of complexity is highly dependent. So that is more or less a limit. The secondly is due to the fact that you're not going to produce a digital twin just because it's beautiful. I think the question is, why do you need it? It's not because you are able to do it that you have to do it. So the question is, as I said, for me, I mean, the digital twin is a wonderful engine to produce high value data, and it's very interesting to provide a good data set for AI. But if you don't need that, it's not necessarily that I mean, that is more or less a weakness. If you don't have to do it if you don't need it.
So thank you, Mia. You continue.
So from what I understand, digital twins can be helpful for optimization, for decision making, for simulations. But digital twins in general, the term has existed for many years. And we were usually thinking about physical models, so equation that would describe a process, a physical process. How does AI help, since we combine and couple digital twins with AI? And let's start with traditional AI. How has that helped in better precision, faster response time? Do you have experience with that?
Me?
Perhaps I can give another example in the context of artistic creation. You know perhaps IRCAM, which is the famous institute on research between science and music, which was created by Pierre Boulez and Pompidou in 1977, and which is dedicated to contemporary music. And for many years, researchers are developing generative agents. And for example, Gérard Assayag is responsible of European Research Council, which is called REACH, for raising co-creativity between human and machines. And the results are that when these agents, which are reactive or which can use some memory about the aesthetic of the musician, when there is a confrontation, the collaboration between the machine and the musician, it is demonstrated that new aesthetics can emerge. So I think that perhaps something which has to be thought about is that when we make collaboration between the man and the machine, some ruptures, some new things can appear, especially in the context of artistic creation.
That's interesting that you talk about creativity and music, because I started my career in applying AI to the music sector. And it's a really good proxy. So I was at the MIT Media Lab where my professor studied at IRCAM. And music is a really good way to understand how the brain functions, and to create AI models or artificial models that mimic how the brain functions is a give and take. So you can model the brain based on how it perceives music, and the same thing with artificial models that understand how the brain functions. So it's a good way, entry point to that. And transitioning from the creative industries to the industrial sector is, I think, a very good segue. So you were talking as well about using generative AI for synthetic data, for example, to feed digital twins. Could you expound on that?
So there are many domains in which we don't have data available. So imagine if you are going, so what happened in one of our experimentation, we were working in a project for European Commission, and the project was to send a satellite, and the satellite, when it opens its wings in the space, there is a part which is carbon fiber and a part which is, let's say, tungsten. And there is no data available to understand at what temperature we should join tungsten with carbon fiber. So we had to analyze that type of data and to create our own data sets to understand that if we put a laser light and that laser light falls on the tungsten and on carbon fiber, when they will join good or not. So such data are not existing. So if we have a model data, we can create now, thanks to generative AI, thousands of samples of data, do some evaluations internally, and then do some testing on the real machines and save money on not wasting our materials. Because to do testing, it's destructive testing. So you have to test, destroy, throw. So I think this data analysis, this data creation helps a lot for us in the industries to save material, to save time, to save energy.
Yeah, that's interesting, because we always say that AI models are only as good as the data you feed them. And having no data at all and being able to generate from scratch a complete set of data to train a new model is really interesting. Guy Alexandre, you talked a lot about the lessons learned from your experience developing a digital twin. Can you expound on that and using AI in that respect? Do you use it today, or is it something that you have on your roadmap?
It's something I have on my map, not my mind personally, but on the map of my lab. The question is because due to the fact that, as I said, due to make, for the digital twin we have made, we needed to produce an engine which is able to produce 3D simulation like CFD on demand. So we needed to use a reduction order modeling system approaches, but it's not AI, because we wanted to be sure about the data that we were able to produce. But at the end, due to the fact that we had at the end a machine which is able to generate a lot of data, we wanted to use this high value data to train AI for predictive maintenance, for, let's say decision-making operation, to just to figure out a way to create a control loop, because it's like for nice as well. It could be interesting as well. And in another point as well, another perspective is to use AI in terms of for scale up. I mean, because we did it for a specific physical model, for a physical system, but it could be very interesting to use this data to imagine what could be the next system. I mean, bigger, smaller, or different at all. And that is some interesting question that we have.
Yeah, it's interesting. We've got an example where in my team we're working on a model of a digester for biomethane production. And we developed both an AI model that takes into account the inputs to expect, to optimize and predict the output in terms of biomethane production. And at the same time, we're developing a biological equation or process to represent what's going on in the digester. But the data approach, the AI-based approach, was so much faster than developing the biological model. So we talked about the infrastructure of having a digital twin based on physical models, the AI layer that can speed up the process. And then we can also think about generative AI not only for synthetic data as the input, but also for the human-machine interface. So can you talk, so if we think of it that way, we can think of generative AI as a wrapper for everything, right? It's a wrapper over the digital twin so that we can interface and interact with it. How do you think about that, Kunal, in your interfacing and work?
I think one of the most important parts of generative AI now is human interaction with the machine. Before, imagine if you have a system and you have to click every button in a dashboard. Now you can talk to the system and say, I don't know, just try to find which machines are not working properly. And the system understands what is machine. It goes to the different dashboards. It's an agentic system, let's say. And it gives you a report in a form that you understand. So it reduces your complexity to interact with the machine. I think this human-machine interaction, thanks to generative AI, thanks to the ability to talk to them as a natural language, is amazing.
Brigitte, maybe do you have examples that you can transfer from the creative industry into the human-machine interface?
With Gen AI as an interface layer.
I know the audio is very hard to hear
yes,
for us.
In fact, I have talked about the use of natural language, which is a natural interface layer. But I think, for example, to generate some 3D elements in the context of theater, for example, we should think about using a gesture, in fact. Other modalities to generate some objects or some images or some music, in fact. And I think it is important in the context of producing some elements in a scene of a theater. And when an actor is playing, we could imagine that in real time, his gesture can produce some elements which augments the scene, for example, not only the language.
Okay.
Okay, thank you. Let's move on to the return on experience. So you have all worked with real systems. And what have you learned in bringing digital twins coupled with AI into production? So maybe, Kunal, you want to elaborate with the human-in-the-loop verification? Or?
Yeah, I think now what we are testing in the futuristic works, so as we discussed, we already have AI in ENGIE, in SEWA working. But we want to go towards generative AI and to have human in the loop, because if you have a data pipeline and if you have a human in the loop, then you can have multiple data pipelines. So that is a very important part. And then what is important is to orchestrate different digital twins, because you can have a digital twin of object one, which has to interact with object 2, and it has to understand these two objects with object 3. Sometimes you will need human in the loop to explain the pipelines, for now at least, till it becomes totally superhuman intelligence. So I think it's quite interesting. It's going, and still we are on the path. It's a progress. It's work in progress. So hopefully soon.
Okay, maybe Guy-Alexandre, you want to talk about your example, which work and the real-world constraint you have encountered?
The constraint, I mean, a lot of constraints. I mean, the main constraint, I would say, is about the interface, because you mentioned the interface, we mentioned the human beings in the loop, and I said, and I'm pretty sure that is a good point for to add AI in the loop as well, because due to the fact that we have a lot of data, and this kind of matching can generate a lot of data. I know I repeat the thing, but I want to say that with this approach, the operator encounter a lot of the data that they didn't do before. So they have the ability to see that it was not impossible to see before. So it's very important to have the right interface to understand what the behavior of the system. And at this point, AI could be a very interesting option, just to make it engine AI as well, because to make things more understandable quickly and faster, almost on demand, for when the digital twin is running. So that is, I mean, that is one constraint.
Thank you, Guy-Alexandre. Maybe it's the last question for you, Brigitte. What makes the digital twin evolve like a human expert?
I have already, in fact, answered to this question. I think what we have to keep in mind is that we must not become lazy. And I think we have to develop expertise, skills, and to be able to analyze and to improve, in fact, and to be able to compare what the digital twin says and what is the ground truth. And so the human beings, the human expertise is completely crucial in this process.
Okay, thank you to our panel. I think now it's time for the Q&A, Mir.
Yeah.
So who wants to
just
go
before
first?
we set the stage for the Q&A, maybe a few words to synthesize and recap a bit the things we said. I think what we said at the end, Brigitte, about we shouldn't get lazy is very important, very interesting. In a world where AI is taking more and more importance, both to model digital twins, but also as a tool to help us in our daily processes, work-wise or in personal life. An example for that is how do we shift to value-added tasks that we as humans continue to do with our expertise, so that we train ourselves to do things that have more value to bring to our environment. An example for that, for example, is in the inspection of transmission lines, power transmission lines, for example. We have teams of people who maintain those transmission lines, and at the moment they have to walk kilometers, drive kilometers to take pictures of these transmission lines between pylons and the wires, and then detect and identify the defects in those lines. And we're trying to work with drones that will automatically capture those images so that the human in the loop can use their expertise to identify the defect rather than having to spend their time walking across kilometers, right? So I think generally we need to identify that. Another aspect that we discussed was around. I think we can sum up pretty much everything as digital twins, both in terms of physical assets and system of systems, for example, but also in terms of processes. The kind of things that we do are being increasingly described as digital twins, and we want to digitize, automate, and use AI to operate those things. So I think that's an interesting way to think about it, and to use this layered approach where we have this physical models on one hand, We add AI to them with more data-based approach. We add generative AI both on the input side to have better data, more data, but also on the interaction side to have human-in-the-loop systems. So I think it's a comprehensive North Star maybe to think about how AI can help us in our processes and systems. So that being said, maybe we'll open the floor to a couple of questions.
So who wants to go first?
Hi, sorry, you talked about connecting digital twins to the plants and information from the plants, for example. Can you understand? Okay. So when you were talking about digital twins, you said that it must have a real-time connection with the plants and with the systems. So which type of signals are you expecting to connect from the plants towards the digital twin? So what type of information are you looking to extract from the plants or from the industry or the machinery to connect to the digital twins?
Me? I mean, it depends obviously of this process itself, because it's if you're more or less you need the sensor and the process, the facility, or have to be described with different kind of sensor. And this kind of sensor will be the input to generate the simulation. So you don't need all the data exactly. I mean, the full data needed. You just need to select properly the input to be sure to generate properly the simulation. Okay? Maybe it's obviously dependent on the physical system. It could be if you try to do the digital twin of a human, it's not the same for than a furnace, or it's not the same for a facility in general. The most when I was talking about the real-time connection is you have to define properly what kind of behavior you want to address, you want to assess, because because you don't necessarily need to understand everything to create the full digital twin. It could be very difficult or impossible.
Thank you for all great panel. My question is around the human and adaptation of the new the technologies that you're developing. So developing digital twin, applying the AI is one thing, but making sure that the tool has been adopted across the business units and using and benefiting from it. How's your experience in terms of the adaptation of the technology? For example, you talked about the biogas and biomethane, so it's a very traditional industry. How we are bringing these new tools, the technologies to their traditional business and accepting that in the industry.
So the question of adoption and the question of digital transformation as a whole. I'll come back to it.
I mean, personally, I have not worked in the same field, so I'm more into Industry 4.0, 5.0, and the problem that we are facing is trustworthiness. How to even trust that the NLP or the systems that we are developing will really work in the way we want them to work. Because you have some data coming out, somebody has to understand that if this data is correct or not. And as you said very nicely, who will certify it? Because in a system that is complex, that is critical, a small mistake can cause a big problem. So I think there's a lot of research going on. It's still a research in progress. It will take time. So I don't have a solution, but it's the question that we are thinking about right now. Thank you.
Yeah, I think this is a great question, and I think it's one of the biggest hurdles we find in the field of digitalization or AI is transformation, adoption to change. One of the things, like you mentioned, is safety, security. If we have command and control systems where humans not only take decisions, but the systems themselves take automated decisions with or without human supervision, how do we make sure that there's no cyber attacks, for example, to those kind of systems? How do you make sure that they follow proper guidelines in terms of biases and things like that? And I think one of the things that happened in the IT industry is the fact that the systems themselves became the process. I think we're not yet there in the field of digital tools or AI-based tools. We have a process that's an operational process in general, and we have tools that augment and bring some value to this process, either individually or as an organization. But I think as long as they are two different streams, they're not merged, we'll face this difficulty. So we need to work towards that.
Any other question?
Thank you very much. I have a question about cybersecurity. It's a hot topic when you treat a lot of a huge of data. So, what is your issue? How do you deal with? What is your purpose? What is your challenges? Could you explain a little bit more about that? Thank you.
I can just share my experience about the digital twin we have made at ENGIE, and when I said that the project was about 4 years, it was more or less 2 years about discussing with cyber with ENGIE IT, I mean the IT of ENGIE, just to define properly what could be the right interface, the right way of communicate. I mean in terms of just to implement the IoT platform. So it's I mean. It's a hot topic because there is only one answer, because there are a lot of data, there are a lot of protocol, and obviously you have the OT systems, your OT interface, you have the IT system, and in the ideal world you want that everything is running together, but it's very, very difficult, and what we have done, it's we just try to build like a single environment closed, because it was the only way to do it properly without, I'd say, have any problem in terms of breach or in terms of misunderstanding in terms of protocol. So that was the only way that we found. But in the real life, when we want to implement properly the real digital twin, we need to discuss more.
Perhaps I can complete. We have developed an avatar of dead composer, Gabriel Fauré, and we have developed a local large language model, and we have filled with correspondence, with books about his biography. So we have trained it, but it was just with information, local information we gave to it. So if it hallucinates, it's not a problem because it's not okay. And in fact, companies, every company would like today to have such local LLM, which can be interpreted as a virtual assistant, but they don't want the data travel to the web. So it is more difficult to design such a local LLM, but it's a way to protect the data of the company.
I read regarding cybersecurity.
No, that's okay.
Just if you want to add, I want just to add something about cybersecurity, or at least security of data, because cybersecurity is a situation, is a question. But for me, the most important problem is the versioning of tools, because each single tool, as I said previously, it's a millefeuille of different tools, and each single program is like matrix. So if single program has its own way to be updated, and sometimes if we want to plug two programs together, it's okay during maybe 2 weeks, 3 weeks, 1 month, I don't know. And it changes every 2 months, 3 months, etc. And if you want to, just to be sure about the right operation, it's just a mess. And it is the first breach for cybersecurity, to be sure that all the tools are working together properly. And I'm not talking about rules or how to use properly the data and all the things about the security. I mean, that is the first step of the first thing of the security, of the reliability, safety, and confidence with data is to be sure to have a robust, let's say, value chain of data, a value chain of program.
So the way you describe it is a very artisanal process. Do you think that there's some path towards standardization and being able to build a digital, so you said it took 2 years plus 2 years to build your digital twin. Do you feel like there's some sort of pathway towards standardization and speeding up the process of creating a system?
If I would like, I would. I think that some companies try to provide an all-in-one system, just to say we will be able to provide you a service which is a digital twin ready to be used. So that is a way to standardize the system. But some way of thinking is not really, to say, fully relevant for your problem. So it's like maybe like Dometic, like Zigbee. It could be some figure out a way to standardize the thing. I know that in France, I don't know if it is for Europe, but I know that in France we have a normalization committee for digital twin standards, etc., etc. But I don't know exactly what is the statute of that.
So I think the question is awesome because we are working on that part. To standardize, it will be very domain specific. So in industrial automation, we have standardization. It's called IDTA, Industrial Digital Twin Association from Germany. And it's about how you standardize using of robots, of AGVs, of machines that build systems. But in energy, I don't know. So at least at European level, you have heard this name called Digital Product Passport. If you have not, you can check it out. It's for the batteries, so that tomorrow if you have a battery and you will understand how the battery's material were purchased, how it was refined, how they were put, how you will reuse the battery again. So it's called the DPP at the EU level. We are working on that now. And there are some standardizations called the AAS. It's called the Asset Administration Shells that can be used. And it's being tried. But in energy, I have not much surety.
Yeah, in energy, the equipment are quite unique in each power plant. I mean, we're moving towards some sort of standardization with solar panels, with wind turbines. But in general, when we talk about thermal power plants, for example, every single one is unique. So it's a lot of individual effort to design them. Yeah.
So
Final word?
I think now we can maybe thank our panelists. So
Yeah.
big up to our panelists. So today, Brigitte d'Andrea Novel, Guy-Alexandre Grandin, Kunal Suri, and Mir Sarkar.
And Elodie. Thank you very much. So just a few closing words. So we're celebrating almost a year of the Powered by AI Talk series, and we're really happy with ENGIE and the MIT Club de France to invite you all to an after party at Le Perchois, which is a rooftop that is very close by, 5 minutes walk from here. It will start at 6 p.m. And the idea is to bring together people in the community around topics linked to AI, sustainability, the energy transition. So you're welcome to join us there from 6 to 10 p.m. tonight. And we will have another series of talks tomorrow around the Emerging Sustainable Technologies report that is going to be presented tomorrow at 2 o'clock in the afternoon, and at 4:45, I believe we will talk about another chapter which is about AI in the emerging sustainable technologies, and the theme, the overarching theme this year is defossilizing the industry. And we will talk about the learning organization of tomorrow. So how do organizations themselves adapt using AI tools? Thank you very much.